Right, Ed, let's answer this question for you. I'll import it, 2 seconds. Okay, there we are. You said you wanted to help with section B. Part A leads you into it. I'm going to have to do part A in order to answer question B. So let's just go through this. Hopefully you rewrote the equation y equals 2x to the half plus 18x to the minus a half minus 1. Undo that. First I can rub that out, I think. There we go. Okay, differentiate it, and we get dy dx equals x to the minus a half minus 4x to the minus 3 over 2. And then we do the second differential, which says d2y by dx squared equals minus a half x to the minus 3 over 2 plus, what do we got? 12 over 2, 6x to the minus 5 over 2. Ooh, can't hardly see that. Okay, I've done that in quite a rush, but hopefully that's all correct. So that's parts A, 1 and 2, dy dx and d2y by dx squared. Part B then says, use calculus to find the coordinates of the stationary point of C. Now essentially this graph, y equals 2x to the half plus 8x to the minus half minus 1, is a curve. And on a curve, it can have stationary points. It can have a maximum point where it stops and goes back down. It can have a minimum point where it stops and goes back up. Or it can have what's called a point of inflection, where it stops and then carries on again. So these things here, this point here, and this point here, are all stationary points. The thing that they all have in common is they've got a gradient of 0. So what we use dy by dx equal to 0. What I'll do is I'll get rid of this first. Okay, I'll go in red now. So 0, dy dx equals x to the minus half, which is 1 over root x, minus, alright, what's this then? It's 4 over root x cubed. Oops, root x, which is then cubed. Okay, this is not easy to solve. Let's just have a look then. We've got, let's move our 4 over root x cubed to one side. So we have 4 over root x cubed, I'm not going to bother, oh, we'll bother with the brackets, equals 1 over root x. Let's cross multiply, let's move that up there, let's move that up there. And what we have then is, we've got 4 root x equals root x cubed. Of course, this really isn't easy to solve. Let's square both sides. So I'm going to square this, and I'm going to square this. So what I'm left with here is 16 x equals x to the 6 divided x cubed. 16 equals x squared. So then we square it, x equals plus or minus 4. There's some tricky algebra there. No wonder you got a little bit unsure of yourself. I'm hoping that's correct. It's come out with a nice number anyway. The only thing that we can just trim this down, it says that x has got to be greater than 0. So our value, our solution for minus 4 is something that we can ignore. Rub that out. So x is 4. Now, so we found the coordinate, the x coordinate of the stationary point. We obviously need the y coordinate. So our x value can go into here. That will tell us what y is. Okay, so let me do it to the side here. So we've got y equals 2 times root 4 plus 18 over root 4 minus 1. So y equals 2 times root 4 is 2 times 2, which is 4, plus 18 over 2, which is 9, minus 1, which is 12. So the answer to this one is going to be 4, 12. Okay, finally, and I'll let you do this last stage, I'll just explain what's happening. Determine whether the stationary point is a maximum or a minimum. Now, right, where was I? Determine whether the stationary point is a maximum or minimum. All you need to do is put your value for x, so there's 4. So that 4 needs to go into your d2y by dx squared. So we plug it into this, in here and in here. All you're looking for then is if you get a positive output or a negative output, and that will just change. You should have the notes on that. If you get a positive output, then it's a minimum point. If it's a negative output, then it's a maximum point. Kind of counterintuitive. I hope that's gone somewhere. I know this is scruffy, I know it's been a rush. Please do let me know if there's anything that you're still unsure of, any moves that I've made, and I'll go through that again. Alright, bye.